Okay, let's just dive right into this. Welcome to this explainer where we're going to explore the hidden digital nervous system of the internet. Every single day, you open a browser, you type in an address, and you hit enter. It feels instant, right? Totally simple. But beneath that surface simplicity is this massive, sprawling labyrinth of infrastructure, heavy cryptography, and completely unseen threats. Today, we aren't just going to talk about networks. We're actually going to travel through them.
Think about it for a second. In the milliseconds between a keystroke and your screen glowing to life, there's quite literally an invisible war being waged. This is the philosophical reality of our modern world. When you enter a URL, you're not just flipping a switch. You're launching this wildly complex sequence of networking, security, and rendering operations. You're essentially sending a beacon out into the void, just hoping it returns intact. So let's trace the exact path of that beacon, starting from the very first spark inside your machine.
The journey actually begins before your command even leaves your computer. Your browser first has to parse the URL. It's taking your human command and breaking it down into actionable machine logic. It literally slices the address into precise components. First up, the protocol, like HTTPS, which dictates the rules of engagement. Then the domain, your target destination. After that is the path, basically the specific corridor you want to walk down. And finally, the query parameters, the exact coordinates of your request. Click, 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 every piece locks perfectly into place.
But knowing the name of a destination isn't enough, is it? The machine needs a numerical IP address to actually get there. Before shouting out into the vast expanse of the internet, the system first looks inward. It performs this rapid scan of its own local memory banks. It's checking the browser cache, the DNS cache, the operating system cache, and finally the local hosts file. It's frantically searching for a memory of this destination. And if it finds nothing, well, it realizes it has to venture out.
Enter DNS, or the Domain Name System. You can think of DNS as the ultimate information broker of the cyber world. Its one and only job is to translate the human-readable domains that we easily understand into the exact numerical IP addresses that machines require to route data. It's like handing a shadowy broker a name in a neon-lit alley, and they hand you back a set of hard coordinates. Without this crucial translation, the digital world would just be this completely unnavigable expanse.
Let's go down the rabbit hole, shall we? Because finding that IP address requires plunging down a really highly structured hierarchy. If your local machine doesn't know the address, it asks a recursive resolver. If that fails, boom, the query hits the root DNS servers at the very top of the internet's spine. From there, it gets directed to top-level domain servers, and finally all the way down to authoritative name servers, which hold the ultimate truth. In just a fraction of a second, we've cascaded down the chain and returned with the exact IP address.
Okay, so armed with the target IP address, the browser starts creating data packets using the TCP/IP networking stack. But before these packets can even leave the building, so to speak, the system has to navigate the local perimeter. This often involves ARP resolution. Think of it like a localized radar sweep, identifying the physical MAC addresses of the hardware on your immediate network. It's basically trying to find the exact physical gateway router that's going to carry your data out into the wild.
Now, machines don't just blindly throw data at each other. They negotiate first. Before a single piece of actual content is sent, TCP communication kicks off with a rigorous three-way handshake. The client sends a synchronization packet, a SYN. The server acknowledges and synchronizes back, a SYN-ACK. And finally, the client acknowledges the receipt with an ACK. 1, 2, 3. The grips lock. A reliable, synchronized connection is officially established across the void.
Picture walking into a hostile environment, completely exposed. Basic HTTP communication is entirely transparent, literally readable by anyone who intercepts it. Not great. But HTTPS, secured by TLS, steps in to forge heavy cryptographic armor around your data. It ensures that as your data travels across these inherently untrusted global networks, it remains a shifting, impenetrable shell to any outside observers.
But forging this armor, it is mathematically intense. The TLS process requires a remarkably sophisticated cryptographic dance. It starts with a certificate exchange to prove identity. Then, public and private key cryptography is fired up to securely communicate. The system validates the certificate, negotiates which complex cipher to use, and finally generates unique, temporary session keys. It is a brilliant, high-speed, mathematical lockpicking sequence ensuring absolute privacy.
All right, with the armored connections securely locked in, it's time to pack the actual payload.
The browser assembles the HTTP request. And this isn't just some simple query, it's a briefcase packed with highly sensitive intelligence. It includes HTTP headers, your cookies, authentication tokens proving exactly who you are, session identifiers, and detailed browser metadata. It is your comprehensive digital footprint, all wrapped up and prepped for transport.
End launch. The packet hurtles into the wasteland of the global internet. The scale of this journey is absolutely epic. Your request physically travels as pulses of light through routers and massive industrial switches. It navigates your ISP's infrastructure, crosses massive internet exchange points, and even plunges deep into the ocean through intercontinental fiber optic cables. It gets routed through content delivery networks, web application firewalls, and massive load balancers, crossing the planet literally in the blink of an eye.
Which brings us to Section 1, the Server Cathedral, Backend Extraction. The request has survived the journey and arrived at its final destination, the backend systems. Think of this place as a colossal digital cathedral, towering monolithic server farms, processing millions of requests a second. This is where the real heavy lifting goes down. Your data has arrived at the gates, and now the backend has to extract exactly what you came looking for.
Deep inside the core of the server, complex operations spin up instantly. The backend doesn't just hand over a static file, it actively constructs your reality. It's processing API calls, reaching deep into sprawling databases, verifying your secure session, and double-checking your identity. It actively generates dynamic, personalized content on the fly, or retrieves perfectly preserved assets right out of its cache. It gathers all the necessary threads of information to weave your response together.
Extraction complete. With the data assembled, the server creates the HTTP response. It bundles up all the raw materials of the web, the structural HTML, the styling CSS, the interactive JavaScript, alongside the images, custom fonts, specific API responses, and some new cookies. This dense packet of digital matter is then shot back out of the server cathedral, completely reversing its journey across the global fiber optic wasteland, racing right back toward your local machine.
When that code finally impacts your browser, the rendering engine takes over to rebuild reality. And it's a masterful, multi-stage architectural process. First, it parses the HTML to construct the DOM, basically the wireframe of the page. It parses the CSS to understand the design. Then it combines them into a render tree, performs intense layout calculations to position every single pixel, executes the JavaScript for logic and movement, and finally uses GPU compositing to paint the final tangible image right onto your physical screen.
It's a truly beautiful process when it works perfectly. But we need to pause here and ask a deeply unsettling question. What happens when the path is compromised? Because the networks we just raced across, they are inherently untrusted. They are dark, crowded, and actively hostile. The reality we just rendered on screen can be a very dangerous illusion if the data was tampered with while crossing the wasteland.
Lurking in that dark infrastructure are some very real monsters. Malicious actors use DNS spoofing to send you to completely fake servers. They execute man-in-the-middle attacks or SSL stripping to tear away your cryptographic armor. They use packet sniffing to read exposed data, deploy malicious proxies, hijack secure sessions, and inject malicious JavaScript or cross-site scripting payloads directly into the code you render. It is a constant barrage. Luckily, the internet fights back. In response to these constant threats, a really formidable array of modern defensive technologies has been forged to act as a shield. HTTPS and TLS provide the heavy encryption, DNSCC secures the information broker's records, HSTS forces secure connections, while web application firewalls filter out the bad traffic. Content security policies, secure cookie flags, and advanced browser sandboxing mechanisms isolate your system, burning away the shadowy parasites attempting to breach your data.
Parsing logic, DNS brokering, encrypted handshakes, intercontinental fiber optic travel, deep database extraction, fending off cryptographic attacks, deploying defensive force fields, and finally complete visual rendering. All of this, the entirety of this wildly complex, invisible cyber war we've just explored, happens usually in under 100 milliseconds. Literally every single time you hit enter. It's just a profound, breathtaking feat of human engineering happening right under our fingertips. So the next time you browse the web, ask yourself, what invisible world did you just command into existence? Thanks for joining me on this explainer. Keep learning and stay secure out there.